We are going to talk about multiplicity now. For example, in the polynomial, f of x equals the quantity x minus 2 squared times the quantity x plus 4 times the quantity x plus 1 squared times the quantity x minus 3. Notice these are all factors, and if you set them equal to 0, this would be x equals 2. The 0, 2 has multiplicity of 2. You tell that by the exponent. The 0, negative 4, set that equal to 0, has multiplicity 1. The exponent's 1. The 0, negative 1 will have multiplicity of 2. And the 0, 3 has multiplicity of 1. It says, although this polynomial only has 4 zeros, we say that it has 6 zeros, counting multiplicity. Also, another way to look at it is if you just square the first item here, I'd have x squared times x squared times x. I would have x to the 6th. So that's why we say that it has 6 zeros. And also the 6th power, remember with the 6th power, and it would be a positive coefficient, those ends are going up. You need to know this so that when you graph these on your calculator, you actually have the picture that you're wanting. Now, the sketch of the graph will touch the x-axis when you have even multiplicities. So at x equals 2 and x equals negative 1, but it will cross the x-axis with odd multiplicity. Touching means this. Say that's a 0. It comes down, it touches, and then goes back up. Crosses through. Now we're going to graph this factored polynomial. It says make sure the graph shows all intercepts, that's x and y, and exhibits the proper end behavior. So I'm going to do my zeros and the multiplicities. So at x equals negative 2, I've got multiplicity of 1. At x equals negative 1, I've got multiplicity of 2. And at this one, I'm going to have x equals 3 halves. It's got multiplicity of 1. Okay? Now another thing, I have technically 4 zeros. That's technically what my exponent is. But check it out. I'd have x times x squared times 2x. So I would end up with 2x to the 4th. Again, my ends would be going up. So I'm going to graph those. Got at negative 2 and negative 1 and at 3 halves. So it's not going to come back after these 2 zeros. So these ends, they're going to go up. It's going to touch here. Now the only way that it can touch here and still stay under the x-axis is if it touches that way. One more thing I'm going to get while I'm here is my y-intercept. Remember, that's when x is equal to 0. So if I put 0 here, I'm going to have a 2. I'm putting 0 in for x. Here I'm going to have a 1 squared, and here put 0 in for x, I get negative 3. So it looks like my y-intercept is going to be negative 6. I think on my y-axis I'll go by 2's. So this is negative 2, negative 4, negative 6. My x-axis I went by 1's. Okay, so 0, negative 6. So I've got that point. So I could put 1 in to see what y value I would get, but I think a quicker way, see if I can get my calculator in here. Go to y equals. Don't graph it. I went ahead and put the function in to save just a tad bit of time, but don't graph it. Do second graph for table and get some points and see if this actually is doing what I said it was going to do. At -3, it'll be at 36. That's way up there. -4, that's even further up. So this end is going up. -2, 0, I've got that. There's -1, 0. So something's happening right in here. We could go find the minimum. We might do that. Here's 0, -6. 1 is at -12. So this is -8, -10, -12. Whether that's my minimum or not, I don't know. But if we graph it, we can find out. I'm going to change my window just a little bit. I need to get over here out of that light. Let me go change my window. So second window, window, Pooh Bear. Why, man, let me make -15. We'll do that. See if we capture the bottom down here. Yep, we do. So this is a minimum right here between -2 and -1. So second trace for the calc menu, number 3. I'll type in -2, type in -1, and I don't guess. So -1.6, almost to -1. So I just have to estimate that. -1.6, almost to 1. So I'm going to do it right there. So my curve is coming down, going up. It's not too bad. Got another minimum over here. Let's see what it is. Second trace for the calc menu, number 3, and it's between 0 and 2. We'll put 2. -12.7. So x 0.8, -12.7. So 0.8, 12.7. Oh, it's just about right there. So let's sketch it. So it's not a bad looking graph. But you can find your zeros, you get an idea. You should also know about end behavior. Count up that multiplicity. And that should match what the largest exponent should be. But you still have to check about the coefficient. Thank you.